Hi, it's Jeff. I'm going to show you my new version of the solenoid engine. If you saw my previous video, I used the coil was in a horizontal position, and the problem with that is, which I didn't like, was that it was hard to control the piston going in and out because the weight of it just wanted to drag on it, and it caused too much friction. So the whole idea is to create the least amount of friction as possible. And this just caused too much friction, and I had to turn the power up too much to get it to work right. It worked, but I wasn't happy with it. Plus, the coil was kind of crappy the way I wound it and everything. So I decided to create a new version here, but I kind of made the coil in a horizontal position this time, in a vertical position. So what you have here, here's the coil, which I wound with, I think it's about 30 or 32 gauge magnet wire. I don't know how many turns are on there because I didn't count them. I just ran it. I just used the whole roll from Radio Shack. And I used the same brass tubing from one of my old pen kits, and I glued a couple washers on there to give it some, to make it more like a spool, and then just wound it up with a drill motor. The way this one works is the piston goes up and down instead of it's vertical instead of horizontal, which works much better. There's no drag. It's real smooth. The piston is created from a nail. Again, it's just a regular, I think it's a 20 penny nail or something like that. And all these connecting rods are from a hobby store. They're all for model airplanes. It's just for the ailerons and all the control surfaces. So I bought a bunch. I think it's 440 rod. This piece I just bent up. It's just a piece of regular steel, and I created this fulcrum out of plastic. So I wanted to make everything as light as possible. Over here, these pieces I made out of copper. These are just copper wire I pounded flat and bent in a U shape and soldered the connecting rod onto it. This is a piece I found in the junk drawer. It's just a little connector to connect onto the crankshaft. So my idea was to keep all these surfaces that touch as thin as possible to get the least amount of surface contact. So I used this aluminum angle iron and drilled a couple holes in them. I drilled them together so they were parallel with one another, and then just ran this through. This disc is made out of plastic. It just gives it a little flywheel weight. This is a reed switch, a magnetic reed switch, and this is a neodymium magnet right there that's just stuck to the shaft. And surprisingly enough, it stays there. It stays there pretty good. I was going to glue it, but it's fun to change the timing on it a little bit, and it creates you could actually change the speed if you trigger the reed switch a little bit later in the cycle. It doesn't give it as much oomph to spin it around. It's powered off of 3 AAA batteries, which are just in a battery case here with a switch on it. I ran all the wiring underneath. Doesn't really look that good, but I just put it on I ran some screws in there to give it some clearance, and just kind of soldered everything together and stuck it up in there. So the timing on it, the idea is to bring this crankshaft around, and as soon as it starts on the upstroke, that's when you want to have the switch come on. So if you rotate the magnet to just about there, I think it's about where it turns it on, then it'll pull the solenoid down, and it'll cause this to pull up, and then by the time it gets up to the top, the switch is not made, and the flywheel effect will carry it around to the next cycle. So, oh, and I also put a little LED down there on the board just to to let you know when the power is actually on the coil. So here we go. I'll turn the switch on, give it a little head start. It runs pretty good. It runs up. You can see the solenoid. That's only 4.5 volts. I didn't really measure the current. I should measure the coil resistance and figure out the current, but it works pretty good. So I hope you enjoy. Talk to you later.